All right, so 2-1, basics of functions and their graphs. Relations are just any set of ordered pairs. The domain is which part of your ordered pair? The x values. So the input values of an ordered pair. Or function. If the domain is your input, then the range is your output. Okay. So we're going to do example B. I'm going to skip A. Okay. So for B, if we want to find the domain in the range, the domain is simply just all of our x values listed out with set braces. So the squiggly bracket, and then just list your x's. So we have 0, 10, 20, 30, 42. And then our range is our y values. So 9.1, 6.7, 10.7, 13.2, 21.7. A function is any relation in which no input value is repeated. So we don't want two x's with different y values. Okay. So if we look at the first example, okay, we have our domain is celebrities, and the range is their earnings. So none of our celebrities are repeated, so this is considered a function. But then if we flip it, going the other direction, because 95 is going to both stern and cow, that means that 95 is repeated, so this is not a function. So looking at C, are any of our x values repeated? No. So is it a function? Yes. All right. We're not going to really worry about independent and dependent variables. Just know your independent variable is your x's, and your dependent variables are your y's. So just like with ordered pairs, not all equations with the variables x and y define functions. If an equation is solved for y and more than one value of y can be obtained for a given x, then the equation does not define y as a function of x. So if we solve for y, we give this first example, x squared plus y equals 4. How would you get y by itself? Subtract the x squared. So y equals negative x squared plus 4. Okay. So if we plug in an x value, if we plug in 0, 0 squared is 0, plus 4 is 4. Okay. There's no way for us to get two y values when we plug in 0. So that means this is a function. Okay. But if we look at b, we want to get y by itself. We're going to start off with subtracting the x squared. So y squared equals negative x squared plus 4. And then how do we get rid of a square? Square root. And when we take the square root, what do we have to put in front? Plus or minus. So y equals plus or minus the square root of negative x squared plus 4. That plus or minus. So anytime we plug in a number, we're always going to get a positive answer and a negative answer. So that means it's not a function. Because of that plus or minus. Okay, so usually whenever you see that plus or minus, automatically it's not a function. Okay, so if you ever start off with y squared, that's a good sign that it's not going to be a function. Okay. Function notation, we're going to change the y and make it f of x. And these are not formal definitions at all. So it means the same thing. F of x, right? X is your input value. F of x is just your y value. So if we look at this example, if f of x equals x squared plus 3x plus 5, evaluate the following. So f of 2. So instead of x, what are we plugging in? 2. So we're going to let x equal 2. So if we plug that in, we get 2 squared plus 3 times 2 plus 5. What is 2 squared? 3 times 2. And 4 plus 6. And 10 plus 5. Good. So our answer is just 15. So you're just plugging in and simplifying. Okay, so let's look at B. We want to find f of x plus 3. So what are we plugging into our function? X plus 3. So this becomes x plus 3 quantity squared plus 3 times the quantity x plus 3 plus 5. Well, how do we square a binomial? Not quite. FOIL. I'm going to go ahead and write this out twice. Some of you guys have started doing the shortcut, and that's perfectly fine. I'll show you afterwards. Okay, distribute. What's 3 times x? 3x. And 3 times 3? Plus 9. Plus 5. Okay, if we FOIL x times x, x squared, x times 3 is 3x, 3 times x, 3x, and 3 times 3. And then bring down the rest. So we have plus 3x. And then let's go ahead and combine. What's 9 plus 5? Plus 14. And then combine like terms again. X squared can't be combined with anything. But what's 3x plus 3x plus another 3x? Good. And then 9 plus 14? 23. So x squared plus 9x plus 23. We don't need to do anything else to it. We don't need to solve for it. We don't need a factor, quadratic formula, nothing. You're just simplifying. All right, and C. f of negative x. So what are we plugging in? So we have negative x squared plus 3 times negative x plus 5. So when we square a negative, it becomes positive. So negative x squared becomes a positive x squared. 3 times negative x minus 3x plus 5. And that is your answer. Nope, we're going to knock out these next couple. Huh? This next part's easy. Vertical line test. Okay, remember, vertical line test says if you can draw a line that's vertical and you only go through one point on the graph, it's a function. So looking at A, if I draw a vertical line anywhere on this graph, am I ever going to intersect more than once? No, which means yes, it's a function. Okay, if we look at B, if I draw a vertical line right here, how many times am I crossing my graph? More than once. So here we got 3 dots, which means it's not a function. C is a fun little graph. But if we draw a vertical line anywhere, are we ever going to cross more than once? No, which means it is a function. And what about a circle? Nope. Circles are going to be our very last section of the semester. Nope, they're fun. Okay, so more than once, not a function. Once is a function. All right, last part. We're going to look at different graphs, domain, range, okay, and then evaluating a function using a graph. Okay, so remember, if it's a closed dot, we use a bracket. If it's an open dot, we use a parenthesis. And if it's an arrow, we use a parenthesis. Okay. Remember, domain is your x values and range is your y values. Okay, the way your book explains it is it takes your graph and it says, okay, shift it down to your x-axis. So if we bring these down, then our domain is from between those 2 lines. Okay, and then for your range, do the same thing, but go to your y-axis. So go from the top of your graph, from the bottom of your graph, and then everything in between is your range. Okay, I don't care which way you think about it. Okay, also, if you struggle with finding the range, turn your paper. You guys are all awesome at finding your domain, and then you get your range and you freak out. Turn your paper. And it's the exact same thing you've been doing. Okay. Yep, always go from smallest to largest. Okay, so we got 2 examples. So on the next page, we're going to use the graph of the function to identify each of the following. First thing we want to find is the domain. Okay, so if we look at this graph, I'm going to zoom it in a little bit, and we want to find the domain. So we're going to go to the far left, and just for notes, I'm going to draw a line. Okay. So the far left x value we have is -2. And then because it's a closed circle, it's going to be a bracket. And then if we go to the right side of our graph, it stops at 1. And since it's an open circle, it's a parenthesis. So our domain is -2 to 1. Okay. Our range, we're going to go from bottom to top. So we find our bottommost y value, which is 1. And it is a point on our graph, which means it's a closed circle. So it's going to have a bracket. And then we're going to go to the top of our graph, which is at 5. And it's a bracket as well because it has a point or a closed stop. Okay. Questions with that? Okay. F of 1, this is the same thing we've been doing. Okay, so if we're finding f of 1, what are we plugging in for x? So this is saying when x equals 1, y equals what? Okay. So on our graph, go to when x is 1, go to your graph. You would think it's 2, but since it's an open circle, we don't include that value. So this actually does not exist. It does not exist. And the only reason why is because of that open circle. If it was closed, then yes, the answer would be 2. Okay, now this part's going to be new. We're going to go backwards now. So find x such that f of x equals 2. F of x is the same thing as what? Y. So this is saying when y equals 2, x equals what? When y equals 2, x equals what? So go to your graph. So would it be 1? No. That one doesn't exist. But then here, at this point, it does exist, and that x value is -1. So let's go over that again. So on this right-hand side, okay, since it's an open circle, that one does not exist. But then on the left-hand side, if we go down to the x value, we get -1. Okay. All right, let's try B, or the second example. Okay, domain. So on the far left, what do we have? -infinity because we have an arrow. And infinity always has parentheses. Okay. And then what about, where's your stopping point? 4 with a bracket. Because that's our farmost right point. Okay, what about our range? What's our bottommost y value? 0, because that's the bottommost y value with a bracket because it's got a closed point. And then what about the uppermost point? It's infinity because it's going to keep going up, which means it's positive infinity. Okay. Looking at C, we want to find f of 1. So f of 1 means that x equals 1. So go to your graph. When x equals 1, find your point. And what would that approximately be? We're going to take a look at estimate. 1.75, 1.8, something along those lines, right? Okay, and then the last one, what if we go backwards? Remember, f of x is the same thing as y. And if y equals 2, what is your x value? It would be 0. This part is the trickiest because it's new. But you're just thinking backwards. Okay.